Hi, in today's session we will be seeing the time complexity of search and sort algorithms. So in the previous videos I have uploaded about the three types of searches and three types of sorting algorithms. So for that particular search and sort algorithm we will see what is the time complexity. Now we will see what is time complexity. Time taken to execute a set of code. To execute a set of code means first let me take a simple example, linear search. In order to execute the linear search, what is the time taken? So in time taken for linear search is order of n, binary search is order of log n, hash function search is order of 1, and bubble sort, selection sort and insertion sort all together is order of n square, because in each and every sort what we are using two loops, outer loop and inner loop. In case of linear search we are using only one loop, one for loop. In case of binary search we are dividing and searching. In case of hash function we are creating a hash function element by using a remainder method. We are using a hash table, we are creating an index of that one, we are pushing the value, and each and every time when we give the key value only one time it is executed. So it is order of only one time it is executed to achieve the goal. So in order to achieve your goal, in order to do the search and sort, how many number of times the loops or set of code is executed, that is the time complexity. Now we will move on in detail how we got this value. First, in the linear search, here this is the program we already discussed in the previous video. If suppose you have not checked the video, you can go back to my playlist and check the particular video, or I will be describing in the description box. So here in linear search we are using only one for loop. That is why our order of value is only n, from I to 0 to n. N is the maximum number of elements. So we are using only one for loop, that is why it is called as order of n. The time complexity for linear search is order of n. Next one, binary search. Here what we are doing, we are dividing the list into half. Again we are dividing until we get a successful search or unsuccessful search. So here we will be having first, last and the mid element. Okay. So what we are doing is log of n. So it is base 2 log of n, where we are dividing the tree until we achieve the search, until we get the key value. That is why it is order of log n, because we are dividing and searching in the list. That is why we are having the binary search time complexity order of log n. Next is hash function search. Here what I am doing is I am creating a hash table, and what I am doing, the modulus of the hash table size with the list element, I am using a remainder method, and that is the index value. You see only one statement here we are using to retrieve the value. We are giving the key hash of key mod 10. So it will check whether this both are equal and flag is set as 1. If flag is 1, it is successful search. So only one instruction, one code is executed. That's why the order of hash function search is 1. Because using hash function we search only one time to retrieve the key value. Next one, we are moving to the sorting, bubble sort, order of n square. Here in bubble sort what we are doing, we are using outer loop and inner loop. So n and n. So n into n is n square. So bubble sort time complexity is order of n square. Next, if you move on to selection sort, the same, we are having outer loop, inner loop. So n into n, n square. Next we move on to insertion sort, order of n square. So we have an outer loop, inner loop, and we are using two for loops, n into n equal to n square.